Hello students, welcome back to the classroom point. In our today's class, we are going to discuss about the spectrum and different type of the spectrums. And in our previous class, we had finished the photoelectric effect, and today we are going to discuss the spectrum. And let us connect the spectrum, photoelectric effect and Planck's quantum theory and how to solve the questions at the end of this video. So let's begin the class now. So spectrum basically defines, let us have the definition about this one. A collection of various electromagnetic radiations on a photographic plate. Is known as spectrum. So here study of the spectrum is known as the spectroscopy. So let's have what is the meaning of the spectrum. Here let us finish the definition of the spectrum. Collection of various electromagnetic radiations. So in our previous classes, we have discussed how many type of electromagnetic radiations are present, and collecting all those electromagnetic radiations on a photographic plate is known as the spectrum. Means arranging of those electromagnetic radiations on a photographic plate in a sequential manner, either decreasing order of their frequency or increasing order of their wavelength, is known as the spectrum. And the study of the spectrums are known as the spectroscopy. So let us discuss, let us take white light. So we know that white light consists of 7 colors. They are violet, indigo, blue, green, yellow, orange and red. So when this white light is allowed to pass through a prism, that prism, the use of this prism is, it separates the different type of electromagnetic radiations. Here all are mixed together and forming the white light. But whenever you allow this white light, which is having these 7 colors, through the prism separates this all type of electromagnetic radiations according to their wavelength, so that it separates like this, and we get the, on a photographic plate, we get all these colors, like violet color comes here, indigo, blue, green, yellow, orange and red. Here I had taken the larger photographic plate and a smaller nickel prism. So I shall erase and take the smaller photographic plate to discuss even the wavelength also. So let us take the smaller one, in which violet, indigo, blue, green, yellow, orange, red. So here the lights are deviating in a different manner. See here, this violet color bending is more, when it comes to the red color bending is less. So which is bending more, that depends on its frequency. Higher the frequency, more the deviation or departure from its straight path. So that instead of going in this way, so violet bends more and red light bends less, because violet frequency is more. So in VGR, this side frequency increases and wavelength decrease, and here frequency is less and whereas wavelength is more. So higher the frequency, more the deviation. So violet deviates more than the red color and remaining colors. So like this separation of the various type of electromagnetic radiations and arranging them in a sequential order on a photographic plate, this is known as the spectrum. So spectrum simply says that the photograph of the electromagnetic radiation. So here These all electromagnetic radiations we got on a photographic plate. Now, how many type of spectrums are present? Spectrum is of two categories basically. Two type of spectrums are present. They are absorption spectrum and emission spectrum. So let us see the definition and the examples of both of these absorption spectrum as well as the emission spectrum. So absorption spectrum, it is obtained from the absorbed light, or else we can say that the light which is left over after the absorption of certain type of the wavelength of the radiations. So let us take a sample here. Any particular sample, this is what we are going to call it as a sample for the absorption. So some absorbing material has been taken, and now let us try to send the white light. So when white light strikes the absorbing material, out of 7 colors that is present in the white light, imagine indigo color has been absorbed by the sample. At the same time, green color also absorbed by the sample. That means sample is removing the 2 colors from the white light. They are indigo as well as green color. So remaining colors, how many colors are there? Remaining 5 colors: violet, blue, yellow, orange, red. They will come out. Means these colors are not absorbed by the sample. Sample has taken only 2 colors. So the remaining light is called as the absorbed light. That is what leftover light. So after absorption, whatever light we are getting, that is called the absorbed light. So when this absorbed light is allowed to pass through the nickel prism or prism, so again it starts separating the electromagnetic radiations based on their frequency. So we are going to get some radiations on the photographic plate. Here violet color not absorbed by the sample, so that violet color we can see here. Indigo color was absorbed, so that indigo color is not present in this absorbed light. So there we can get the dark space. Blue color is not absorbed, so that blue color appears on the photographic plate. Again green color has been removed by the sample, that means it absorbed. So there again you will get the dark space. Yellow, orange, red not absorbed, so that they come out yellow, orange and red. So in the absorption spectrum, after absorbing some amount of certain type of the electromagnetic radiations, we are getting the remaining electromagnetic radiations on the photographic plate. So whichever the electromagnetic radiations are absorbed, they are not appearing on the photographic plate. So it looks like that. So the dark lines appears on the bright background. This photographic plate is a bright background, so on which dark spaces are obtained. So here in the case of the absorption spectrum, we can say that dark lines obtained on the bright background. Now let's come to the emission spectrum. So emission spectrum means it is obtained from the emitted radiation. That means whichever source, example, let us take some sources like sun or else a candle or any igniting material, etc., whatever the materials you have taken. So from where the exactly released radiation, that is emitted radiation, is coming, so that emitted radiation, when allowed to pass through the prism, so it separates those electromagnetic radiations again based on their frequencies, and these are collected on the photographic plate. So that spectrum means directly light when from the source, whichever light is released, so that light if directly hit the prism, so that separation of the electromagnetic radiation occurs, and which we collect on the photographic plate. That is what called the emission spectrum. Then here, when it again come to the absorption spectrum, in the absorption spectrum, two colors, both indigo and green colors, have been removed. Now, can we call this spectrum also as a emission spectrum? We cannot call this light as an emitted light. Why? Because this light is coming through the some absorbing material, not directly from the source. Here directly source light is hitting the prism. Now, if you want to get the emitted radiation from here, then remove the source. And earlier here indigo and green colors have been absorbed by the absorbing material. So whenever you remove the source, initially these material particles absorb the indigo and green color, they went to the excited state. So when they are coming to the lower ground level, they release the same amount of energy. So when that energy is passed through the prism, again we get the lights. That means these both colors can be collected in the photographic plate. We don't get the violet. Why? Because violet color is not present. But which colors are present? Indigo is present. Indigo color is obtained. Again, which color is present? Green color is obtained. Remaining colors we don't get now. Now this one can be called as the emission spectrum. Why? Because now in this spectrum obtained from the source, now this absorbing material is releasing the energy or the light, so that's why it is called the source now. So this is called the emission spectrum. Now if you look like this, if you look both of these absorption spectrum and emission spectrum, wherever the lines are missed in the absorption spectrum, the same area the lines appear in the emission spectrum. Means the missing area lines are obtained in the emission spectrum. That's why these two are called as photographic negative to each other. So photo negative to each other, and because wherever it is missing, there it is appearing. Now in this case, see here, this area completely one line is obtained, this area completely one line is obtained. So means bright lines are formed because lines are appearing now. That's why in the case of emission spectrum we can say that bright lines are obtained in the dark background. Now let us see how many types of emission spectrum and absorption spectrum are present. So emission spectrum basically is of two types. They are, one is continuous spectrum, second one is a discontinuous spectrum. So continuous spectrum means when the light is passed through the prism, whatever the lines are obtained in the photographic plate, like in the VIBGR. So in the case of VIBGR, we cannot separate the violet color with the indigo color with the blue color and so on. Why? Because almost they merged with each other. So when the spectral lines are obtained by merging one radiation with the another radiation is known as the continuous spectrum. So that exactly we cannot say where violet color has end and where indigo color has begin. So that violet last part mixed with the indigo, indigo last part mixed with the blue, and blue last part mixed with the green, and so on. So that continuously the spectrum has been obtained. So such type of the spectrums are known as the continuous spectrum. Discontinuous spectrum means, so fine space is present among the various electromagnetic radiations. So in the case of discontinuous spectrum, when the light is passed through the prism, so we get the spectral lines, but there is a little gap, or else we can exactly say that where one color ends and from where another color has begun. So we can easily distinctly can say that the range of the each electromagnetic radiation, so such type of electromagnetic spectrums are known as the discontinuous spectrum. So that here we can say that like this, here one radiation, here another radiation, so that exactly we can say where the starting part and ending part of the electromagnetic radiation. So this discontinuous spectrum is again of two categories. One is line spectrum, second one is band spectrum. So line spectrum means the spectral lines obtained in the form of the finely spaced lines. So such type of the spectrum is known as the line spectrum, and in the case of the band spectrum, the spectral lines are obtained in the form of the bands. That means a group of spectral lines merged with each other and forms one particular band, and afterwards again another particular band will begin. So like this. So this is known as the band spectrum. Now let us see which elements gives the line spectrum and which one gives the band spectrum. Line spectrum is the characteristic spectrum of atoms. This is also known as the fingerprint spectrum of the atoms. Means every atom gives its own line spectrum. No two atoms gives the same line spectrum. That's why it is known as the fingerprint spectrum of the atoms, or the characteristic spectrum of the atoms. And by using this line spectrum, scientists were able to discover some elements like helium. Helium was identified in the sun atmosphere using the spectroscopic method, and afterwards rubidium, cesium, gallium, indium, thallium, and scandium. So these elements are obtained, discovered in their minerals using the spectral analysis. That's why line spectrum is a characteristic spectrum of the atoms. Then what about the band spectrum? Band spectrum is given by the molecules, and it is not the characteristic spectrum of the molecules. Any two molecules may give the same type of the band spectrum. So why molecules are giving the band spectrum and why atoms are giving the line spectrum? Atom in single one is present, whereas in the molecule more than one type of atoms are present. So these atoms grouping together so that they can produce the bands. So here this band is coming from the merging of one atomic spectrum with another atomic spectrum. Here also this is coming with the merging of the one atomic spectrum with the another atomic spectrum. So when of the atomic spectrums merge with each other, the spatial lines become the band that gives the band spectrum for the molecules, because molecules contain more than one atom, whereas here singular one is present. That's why it is giving the finely spatial lines, that is line spectrum. So this is about the spectrum and the spectral characteristics.